Thank you, Matt. It's great to be here. I will be showing you as much as I can as soon as my computer unfreezes. Hopefully now, perfect. So good. I can start projecting, the trail of the live, and here we go. So yeah, that's right. I will be discussing a little bit how you can secure your database and your data to make sure that the agents that are basically going and do their own stuff will be doing it in compliance with the rule that you set to make sure that your data access is secure. So let's start with the agentic AI challenge. Then we'll go over row-level security to make sure that you can, sleep at night in peace and being sure that your data is securely protected by Azure SQL and SQL Server, no matter what agents will be doing. And then we'll also discuss how you can actually use the newly announced SQL MCP server tool to make sure that your database can connect to AI Foundry, for example, so that you can build a very nice agentic application in a breeze. So let's go over it right away. And let's start with the agentic AI challenge. Well, the main point is that things are changing, as you probably discovered already. And AI agents will actually write and execute SQL code for you at runtime. This means you don't have control on SQL code that gets executed anymore. And while that is great, because agents can really do fantastic stuff, I'll show you some samples, that's also a little bit scary sometimes, right? Because before this new year we are entering in, before these days, so let's say in the old days, before AI agents, you could trust your developer to actually write the right SQL code with the right where clause to make sure that whatever application I'm using, I will only be allowed to access what I need to access or I'm allowed to access, right? So the application will just run a query on the database, make sure that the right where clause with my name or my ID, it's always added to the query being sent to the database, and everything is right. But now with AI agents, you will not write, or none of your developer will write SQL code, because you will tell agents what you want to do, and the agents will actually write the SQL code for you. So how do you know, and how can you be sure that the agents will actually put the right where clause whenever it's needed, for example, to comply with security? And even if they do, how can you be sure that no one is using a malicious prompt or maybe just wrong data, or again, there could be attack using data injection with malicious data in your database, maybe that kind of tricks the AI agent to do more than it should be doing. Or maybe you decide to use something on premises, you are experimenting with a new model, and it's not smart enough to actually understand how to apply the security to your queries. So you need to figure out a way to do it once and for all, no matter what agents are using, no matter what LLM, no matter where the agent is coming from. And that's how you actually sleep well at night. But before going there, let's see the nice and fun part and super cool, I would say, part of agents. So let me move to my code. All the demo I'm showing is also available on GitHub. You will get the links later. But basically what I've built here, since I'm more a backend guy, I built a console application where you can chat with your own data. And I created two agents, and that's very important. One orchestrator agent that knows about all the tables in the database. Because we discovered, and probably you realized already, that if you just throw the entire schema, and if the database is not trivial, like the entire schema can be a lot of tables, like 100 or even 1,000. So if you throw the entire schema to the agent, at some point it gets confused, right? Like humans. If I want to have the solution for some queries I'm running, I may need only to focus on few tables, not the whole tables that I have in my database. So we have two agents here. One is what I call orchestrator, that knows about all the tables in the database, but at a very high level. So it knows the existence of table A and table B, let's say sales and customers and products. And it doesn't know exactly how each table is done. It doesn't know about the schema. It doesn't know about any peculiar kind of ways to query those tables. But it just knows that the table exists and what is the purpose of the table. So this is the orchestrator. And it's the one that you will be discussing with in order to tell him or tell it what you want to get done. And the orchestrator agent will figure out the steps needed to answer your query, and it's all defined here in the prompt that the system prompt I'm passing to an agent. So the agent, can break the request in smaller steps, and then can use another more specialized agent, the one that I call the specialized database agent, that instead is able to only see a subset of tables, the one that are specified by the orchestrator agent based on the request or the steps it is taking to satisfy your request. And for those tables, the specialized agents have access to everything, all the metadata, all the information, all the schema details, everything, right? So the specialized agent will actually be the one who is creating the query, right, and running it. So there will be some back and forth between the orchestrator agent and the specialized agent to basically work together to come up with a solution to your queries. And your query, actually your natural language query, can be something pretty complex, right? Like, let me show you. So let's start this application in debug mode, so we can see also what happens behind the scene. And this application is right now using semantic kernel. I will soon move it to the agent framework, but the principle is pretty much the same. So here I am accessing to Venturos 2025. I'm using SQL Server 2025 on my machine. I'm using the SQL Express edition, which is free to everyone. And you can do the same also in Azure if you want, because we also have a free tier in Azure. And so it's up to you to choose where you want to run this, but I'm just using on-premises for the sake of this demo. And my orchestrator agent has been informed about the existing of 66 tables. So not really a trivial situation, but still not super complicated, but good enough for this demo. And now what I want to ask, and the prompts again are part also of the example, I want to ask if the agent can help me to figure out what is the best selling product in each market we operate, because I'm assuming here I'm using this database that is from my company that operates in a worldwide scenario. And then I also want to understand what would be the cross-selling opportunity with another product in each of those markets. So literally not something easy to ask, right? And that's exactly what people want to do today with AI and data. They want to talk and discuss with their data. So let's see how it is behaves. So let me put it full screen, and basically I just asked the question. So now the orchestrator agent came up with a plan. So these are the tables that it needs. And then these are the two steps that it needs to accomplish. So now that the orchestrator has a plan, is moving to the specialized agent to ask something more specific, like the orchestrator is asking the specialized agent, return the best-selling product by total sales and quantity or amount in each market, and blah, 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 right? And use this table because those are the tables I know out of the 66 that we have that are those the ones that are relevant for answering this question. And then the specialized agent can start and run a query, even a complex one, right? Here is really using advanced techniques like row number and partitioning, aggregates, and starting and going on. The original request was split in two different subtasks. So that's why you see two different queries, one with the interim result and the second one with the other interim result. And then the specialized agents are returning the result of these two tasks, the orchestrator is putting everything together, and now we have an answer. That is fantastic, honestly, because this is exactly what every customer I discuss with want to do. Talk with the data, be able to interact with the database in a natural language, brainstorm, find insights. And that is where everyone is, wow, this is what I want. But then immediately after that, usually someone start to ask a more security-related question. And those are, well, what happens if, you're a good guy, Davide, but what happens if by mistake or because you want to force a little bit the hand of the system, you start to ask questions to the orchestrator or even to each specialized agent, something that you should not ask, right? Something that maybe allows you to get insight on some data you should not be able to see. For example, in this database, we have data from all regions of the world, but I am in the Pacific Northwest, so I may assume that I'm only allowed to see data from the Pacific Northwest, right? Maybe I'm trying to, do something strange or something interesting with another region, let's say France, and I'm trying to sneak in some request about France that I should not be seeing, but I'm trying to force my agent to actually give that data to me. And luckily in SQL Server since ages, so more than 20 years ago now, we have row-level security. Row-level security is the answer to all these security challenges that agents start to bring into play, right? Because with row-level security, even if you have a query written by you or written by an agent that completely lacks a where clause, you will only be able to see, or the agent in this case will only be able to see only the rows that you want it to see. Let me show you. It's easier said than explained, so let's go here, let's go back to our solution. Let me stop the application for a second because I want to go for a second to database, and here I have my row level security configured. It's not very complicated to set up. It just requires most likely a table where you want to store, for example, who can access to what. So let me show you this new table I created called security sales territory access. Let me connect to my SQL Experts database here, and specifically to the right database, so AdventureWorks. Here we go. Let me execute the query again. And you can see that my account can only access the territory, or this is at least what I wish, should only be able to access the territory 1 and 4, right? And since my agent will be acting on my behalf with my security in this specific sample, basically I just want to have the agent to have my security level. So that's why I assigned the security level to me. Now, what I need to do is set up the row level security, which involves creating a function in SQL that filters the rows, and then creating the security policy and applying that function that filters the row to each table. Now, the function is not really called by each row, because that will be too slow, but logically we can think something like that, right? So every time a row is about to be returned to the user, this function actually acts as a filter deep in the engine, so that the row is checked with the permission if it should be returned or not. Again, this is just logical. Practically speaking, it runs in a much more efficient way, but ideally that's what happened. So right now, let me make sure that the policy that I set is off for now, so I can take any query. Let's say I have this query here, and I applied the security to the sales territory. I run my query. Again, let me connect to the database, but the right one. Here we go, and let me run the query again. And you will see that now I can access all the territories, which is not what we want, right? At the same time, I can also access all customers, because it doesn't really matter in which territory they have. I have full access to all the database here, but that's not what we want. What we want is make sure that I can only access the Pacific region of the territories that I have. So what I need to do right now, I already configured, as said before, the policy. I just need to enable it. So let me go and turn it on. And now I can go back. I'm logged in as myself, which, by the way, in this machine, I'm the administrator. And now, even being an administrator, let me show you what happens if I query sales territory, no filters, no other options to filter data. I can only see what the policy allows me to see. And maybe you can think that I can play some trick and say, hey, let's do where 1 equals 1, so we can kind of trick the query optimizer. Well, the query optimizer can't be tricked in this case. It still shows me only the rows that are compliant with the policy I have set. And the same is for customers, right? So now I can only see all the customers that I want, but as long as they are in the sales territory. Now let's go back for a second. Let's do one sample here. Let's first of all disable the policy again, now that you understood how you can enable it and how it works. So right now we are back to the square root, so where we are completely free to access everything, and let's just run our little application again. So let me run again this here, again in debug mode, so you can see what happens behind the scene. And I will use another prompt this time. I have prepared this one, so you can easily see what happens behind the scene with and without the row level security enabled. So let me ask the AI agent some help in analyzing something in France where I should not be able to have access to. And the AI agent here is absolutely, happy to help me and get data about all the details of sales in France and who is doing what, all very sensitive data, right, that I should not be able to see. So let me stop the application. I could have also just cleaned the memory of my agent, but just to start fresh. And now let me enable the policy. So turning it on. And let's run the application again. And let's see what happens right now. So let's ask exactly the same question. Let's see what the agents came up with. Probably the same query. And now it appears that there are no records that says for France territory. So please make sure that the agent, even if it's, in this case, rightfully so, trying to apply a search for France, in this case using the regional code, is still not able to see and access any data it shouldn't access since it's acting on my behalf, and so everything is secured. And again, remember that this query here is not something is written in your code, as we have learned in previous sessions. This query will be created by the AI agents, so you don't really have a lot of control on it. Yes, you can try again to force some workflows with the prompts and maybe put double check, but the moment you try to constrain too much what the agent can do in terms of creating SQL queries, you also limit the capability for the end user to interact with the agent with your data, right? So you don't really want to limit that much in terms of capabilities and flexibility, but you do really want to make sure that the security is always applied, no matter who writes the query, how the query is written, and who is going to execute it. So this is, I think it's the absolute feature that you need to keep in mind whenever you think of creating an agent that can access your data and you plan to allow the agent to write arbitrary SQL queries for you. Of course, if you use store procedure and function, you have a little bit more option. But again, using those features in some case might be limiting. So if you really want the agent to answer, as I'm doing right now, any question, you need to let the agent create the SQL for you. And then you need to have row-level security and all the other security objects that you are probably already aware of, like column-level security, the object security, to make sure that agents can only access what you want them to access. Now, with that said, let's move to the next step of this short presentation, which is about, this is great, Davide, but I will be using most likely AI Foundry and agents, and I don't really want them to be able to just write random SQL queries, because again, that's exciting, but maybe I have a use case where it will be much better if my agent can actually see the database as a set of tools exposed via MCP. That is great, and in fact, we have created a SQL MCP server, which is in preview right now, and is a self-hosted container, basically an application that allows you to take your database, select the storage procedure, select the entities that you want to expose, and turn them into tools that can be used by MCP. So this means that any agents can safely and securely connect to the tools that are exposed via the MCP. It's horizontally scalable because this solution can be hosted in a container, one of my favorite ways to host the Azure Container Apps, and it can easily scale horizontally. And of course, it's secure because this solution is based on something called Data API Builder that allows you to exactly regulate how do you want to expose your database as an API. Data API Builder always supported REST and GraphQL, so you could even today take your database and turn it into a GraphQL service or a REST service, just like with a flick of your finger, because it just takes a second. But then you can also make sure that you have a deep and well-defined security layer, again, provided by Data API Builder, so that you can choose exactly who can access what using the claims that are provided when you perform authentication. Now, to GraphQL and REST, we added the support for MCP. So MCP, again, it's in preview. It's very easy to set up. It's basically you download Data API Builder, which is a .NET application, configure a configuration file, just to tell the Data API Builder what should be exposed and what not, what are the security condition that you want to apply, and then basically you even enrich your configuration with semantic notation, so you can describe what a storage procedure is for, on what is the table purpose, or what is a view purpose, so that the AI can have as much as information as needed, and then you just publish it on Azure Container Apps in my specific case, and then you have an MCP endpoint. MCP endpoint that you can use, for example, for testing. I'm using VS Code, so I can see the tools available, or you can connect to it from AI Foundry, which is exactly what I'm going to do right now. So I'm in AI Foundry here, and what I did is that I just created a tool in AI Foundry that connects to the MCP endpoint created by Data API Builder, hosted in Azure Container Apps. And now I can start to chat with my data saying, hey, I want to find a good product for a teenager boy passionate about Formula One. So the agent is now using the scribe entity to figure out what database expose. Then he's asking me the permission to execute the stored procedure search product. Stored procedure that, by the way, internally is using vector search and the RAG pattern to actually provide a rich answer, not just a simple where clause. And then it's returning the data. And here we have, for example, the answer that says, yeah, from your product catalog, I see you have F1 for PS5 or Xbox ROG Ally. That's definitely a great choice for your teenager boy. Now, how this helps you to build great solution. This is what we envision the modernization is for existing application. Let's say you have your insurance solution where you can manage your accounts, right? So what happens in future is that you can add a chatbot experience, but you want that chatbot experience to be integrated with the rest of your data in your solution. So here you just ask to list your customer, and you notice that one customer needs to have some updates. For example, John's name is actually Marcus. So, because there is an error in database. So you chat with it, or maybe in future you will talk with it, and the agent will actually call the stored procedure or issue the right SQL command via an MCP call that is exposed, as I just showed you how, and then correct the data. And then you immediately see the answer in your application. Then maybe you add or update other information about like new ring added after wedding, and more details, so everything logged, of course, because you want to have a trace of what happened in the database to make sure that the agent is always helping you in a way that you can always understand what happened in case you have to figure out something later. So this is the architecture that I'm super excited that it's doable today. Right now, you have SQL Server, Azure SQL, Fabric SQL, all able to host AI features inside their engine and connect to OpenAI, and then you can take your stored procedure view or table, expose it as a MCP endpoint via Data API Builder, and then connect it to AI Foundry to basically build the agent of your dream that is secure, capable to answer any question and access the data in the way you want it. This is what we have built for you, and if you are a developer asking, that's great. Now I want to deploy it from on-premises like you did, David, in the cloud. What is database I should use? I go to Azure and I see a bazillion of options. Well, the answer is very easy. Go with Hyperscale. Hyperscale is a database that we have re-architected to be cloud-born. So it's Azure SQL Server, but with an Azure SQL kind of approach, so everything is distributed. It can scale as much as you want. It gives you the peace of mind that you can grow as much as you need and do all the AI kind of features and evolution that you want with the peace of mind that you don't have to change or re-architect your database if you grow more than what you expect or as much as you expect. And then I have some resources here. This demo is available for you to download. It completely works on premises. If you want, you can even use Olama to run everything completely on premises. I was using OpenAI today. But then there are many questions usually that comes after seeing this. So where I can download the API Builder. I have some question about how to design my table, why you choose Orchestrator and a specialized agent. And so you have all the questions answered in the article's FAQ on AI and vectors, developer edition, link to download the latest and greatest 2025. Plenty of AI samples. We have 61 samples reached with SQL and AI. And then, of course, also the Azure SQL database offer in case you want to deploy everything in the cloud for free. That's pretty much what I have for you. Make sure to connect on LinkedIn and Reddit. And thanks a lot for listening. I hope you enjoyed it.